So for Lower Granite Dam, we just finished installing an upgraded component of the Lower Granite JBS, and with that we did essentially a week of detailed biological testing that Alison and P&L folks did for us before we went into the main season. I think most folks have seen the results for that, which is essentially repeated here. A few additional details that Alison's been able to work up. Otherwise, with that, I'll just turn it over to Alison.
So this study was really just a quick preseason evaluation of the new JBS to make sure that there were no red flags before the smolt outmigration season started. We had three main objectives for the project. The first being looking at fish condition or the change in fish condition for fish that were passing through the facility bypass route. Go ahead, Billy. The next was looking at the travel rate, and we were looking at that for fish that passed through the facility and as well as the primary bypass components of the JBS. And you can go ahead. And the last was the sensor fish evaluation. And there was two components to that. One was evaluating the new emergency bypass route, as well as looking at the feasibility of looking at the entire JBS using sensor fish. So this is just a schematic of the Lower Granite juvenile bypass system for those of you that aren't familiar with it. We have in the kind of dark gray color that you can see here, that's the primary route that the fish that were used in our study took through the system. All of the boxes with the black outline, it's a little difficult to see, I apologize. These represent the pit tag readers that are present at Lower Granite Dam. And there's some other routes that the fish did take, but this is the primary route through the separator into the sort by code tank. We also installed two temporary pit readers in the orifices for Unit 1A and 5A. Those are denoted by the red here, and that allowed us to differentiate the gate well residence time from the travel time through the rest of the system. And those were just temporary for the 2018 outmigration season. So for our first objective, looking at fish condition, our general methods were we raised the fish at the P&L Aquatics Research Lab and planted them with pit tags, did a pre-release condition assessment, and documented any existing injuries with photos. On the table on the right here, you can see all the different categories of conditions that we looked for, the most notably being descaling. We categorized it as less than 5%, 5 to 20%, 21 to 50%, and greater than 50%. Then we held the fish overnight with flow-through water to allow them to recover, and then in the following morning we released them directly into the gate wells using this flex hose and PVC system that was used, a similar methodology to the previous evaluations at Lower Granite. Once the fish passed through the system, using the sort by code system, we diverted them to the sort by code tank over here. And we did have a few fish that went into the sample room as part of the routine sampling at Lower Granite. Once the fish were recovered, we reassessed their injuries and we photographed them again. In terms of travel rates, as I mentioned, we installed some temporary pit detectors in the orifices for units 1 and 5A. And I'm going to be talking today about those fish that we released specifically into the gate wells, but I'm also going to talk about two other groups of fish that passed through the JBS in the 2018 season, just to give some context and some variety in terms of the passage routes and timing. The first group is what we're calling the PCE fish. Those are the fish that we tagged and released directly into the gate wells. Because of the orifice pit detectors and all of the pit detectors subsequently downstream, we're able to look at the travel rates from the orifice through to the separator exit. You can see here the sample sizes and the median fork length for those fish. Because of the subsequent passage and survival study going on at Lower Granite this year, we were also able to look at the fish that were tagged with acoustic transmitters and pit tags that were released upstream of Lower Granite and then subsequently passed through the JBS. These fish were run of the river. They were collected in the sample room at Lower Granite Dam, and then tagged and released upstream. We had a very low sample size of those that went through units 1A and 5A, so we can't really do any reliable travel rate estimation with that low sample size. So we're using the starting point as the full flow bypass detector all the way to the separator exit. We also can take advantage of the acoustic telemetry data because of the cabled and autonomous arrays that were there as part of the passage and survival study. And so we also estimated travel rates from the cabled array, which is on the upstream face of the dam, to the tail race arrays. And finally, we have our other yearling Chinook category. These were run-of-the-river fish that were pit tagged somewhere upstream of Lower Granite, made their way to Granite and passed through the JBS and were detected on any of the pit detectors within the system. Because of the high sample sizes going through the orifices that had those temporary pit readers, we're able to look at travel rates from the orifice to the separator exit. One thing to note about this group is this median fork length of 105 millimeters is based on the time when they were tagged, not necessarily the size of the fish that as they were passing the dam. So our third objective was using the sensor fish to evaluate the hydraulic conditions within the new JBS. Our first kind of objective within that was to look at the entire JBS. We did this concurrently with the live fish study in early April of this year. We released just over 50 fish into each of the units, directly into the orifice flow going into the collection channel, and we recovered the sensor fish down in the juvenile fish facility. We also conducted a number of releases at different places within the JBS so that we could get a better understanding of the data and the timing that we were collecting. This is the first time that we've used sensor fish to evaluate a JBS, so we don't really have a lot to compare it to. And just this past November, we evaluated the emergency bypass route within the dam, and we're currently working on processing that data, and so those results will be presented in the final report. So onto our results. Our orifice pit detection efficiency was pretty surprising to us. We saw 42 and 66% detection efficiency in gate wells 1A and 5A. And this is based on just the fish that we released directly into the gate wells themselves. And because these were so successful, we ended up just deploying them throughout the entire outmigration season until September when we retrieved the equipment. In terms of the travel rates, or the travel fates, most of our fish ended up in the sort by code tank, which is located here, again denoted by this kind of greeny-gray path. But we did have fish that went to were last detected at other places within the JFF. We had quite a few fish that were last detected at the diversion sort by code pit reader. We did find on the first day of releases that there was an issue with the sort by code system, and we worked with Nicole at Patagus to really quickly rectify that. But we did have quite a few fish last detected there. We had a few fish that were detected going into the river exit here. A few fish that went to the adult fish return at the end of the separator. And then we had a very small number of fish that were last detected at the full flow bypass and were never heard from again. As I mentioned, most of our fish went to the sort by code tank, just under 75% of them, and we had a handful of fish that went to the sample room. So when we looked at fish condition of the fish that were recaptured, descaling, as we've seen in previous studies, was the primary condition change that we observed. We had a total of 5.6% of our fish had a change in descaling. The vast majority of those fish went from less than 5 to 20% descaling. Just to put it into context, with the typical SMP operations, we saw a total of 9 fish that had greater than 20% descaling after they went through the JBS. That equates to about 0.01% of the fish that we released. All the other conditions that we looked for were really much less common, less than 1% for each of them. And the descaling rates that we saw, or the change in descaling rates that we saw, were significantly lower than those of previous evaluations at the Lower Granite JBS. Next, we're going to move on to the travel rates results. You're going to see some similar figures and layout of the slide, so I'll just take a little bit more time on this one to explain it. Down here we have our outline, or kind of our rough schematic of the JFF, or the JBS, excuse me. The green dot represents the start point for our travel rate calculation, and the red dot represents our end point. For the first set of information I'm going to present is from the release to the separator exit. We wanted to compare to the previous studies of the old JBS. Just to note, there was no orifice detector in 2013 and 14, and so we had to compare from release until the separator exit. So just to orient you to these box plots, the line in the middle represents the median. The box itself represents the 25th and the 75th percentile. The whiskers represent the 90th and the 10th percentile, and the solid dots represent the 5th and the 95th percentile. The open circles represent the mean travel rates for each of the individual groups. And the table below shows you the sample size, the median length, travel distance, which did change between the old and the new JBS, as well as the median travel time. So you don't have to do any math to figure out how long the fish were taking to go through the system. Overall, when we compared the pre and post data, we did see that the fish that we released into the gate wells this year did travel at a slower rate compared to previous years, but it was still within just about an hour. Most of the fish were out of the JBS. Moving on, looking at the orifice detection to the separator exit, we were able to compare the fish that we released into the gate wells to those run-of-the-river fish that were pit tagged and moving through the JBS. And we excluded any of the fish that were included in the acoustic telemetry study just to reduce any kind of influence there. Again, we saw that the fish that we released into the gate wells this year did move at a slower rate, but in terms of the matter of minutes or time that the fish were spending in the JBS, it was within an hour and a half before the fish were out into the sort by code tank for the most part, or into the river. And finally, we wanted to kind of line up everybody together, looking at from the full flow bypass to the separator exit. We're able to look at the PCE fish, so those fish we released into the gate well, the acoustic tagged fish that were moving through the JBS, and then any of the other fish that moved through the JBS during the outmigration season. Again, we see that the PCE fish were the slowest of the group, but in terms of actual time, the fish are still getting out of the JBS relatively quickly, within an hour and 15 minutes or so. One thing to note about these results is that the PCE fish were all released in 1 week in early April. The PSE fish were released from the middle of April through the end of May of this year, and the other fish could have passed anywhere from the beginning of April through the end of September, when we retrieved the orifice pit readers. So there's some timing differences that could be associated with some of the passage differences we see. And finally, just to kind of plot everything together so you can compare all of the groups, we have the previous studies here on the left side. The PCE fish, those are the fish that we released into the gate well, the acoustic tagged fish, and then the other fish. While we did see that the PCE fish did travel at a slower rate, the run-of-the-river fish that went through the JBS this year did so at a travel rate that's pretty similar to what we saw in the previous JBS. So again, there could be some timing and other study design factors that might be influencing the PCE fish travel rates. We also looked at the acoustic telemetry data because we wanted to better understand how that correlated to the pit tag data. We had a cabled array mounted on the upstream face of Lower Granite Dam. We had an autonomous node in the tail race right below the primary outfall pipe, and then we had a tail race array about 1 kilometer downstream of the dam. And just to be clear on this slide, all of these fish that I'm going to talk about actually went through the JBS, so they went this way, not just directly through the dam. So we can see from from the acoustic telemetry data that the travel rates of the acoustic tagged fish was actually pretty comparable to what we calculated with the pit tag data. And we can see that once the fish hit the tail race, they start speeding up quite a bit, which is what we would expect. So moving on to the sensor fish, one of the interesting questions we had was whether or not the sensor fish were representative of real fish. What we found was that they're moving quite a bit faster through the system. Sensor fish, for those of you who aren't familiar, are neutrally buoyant, and they're passively moving through the system, so not able to fight the flow at all. We did find that the sensor fish, as they were moving through the system, their travel rates did change, and we saw they moved the fastest through from the primary dewatering structure through to the separator. In terms of the typical sensor fish results that we found, one of the challenges associated with the JBS is that it's quite a bit longer than the typical structures that we evaluate using sensor fish. And so there was really a need to increase the recording time of the data that we could collect. We were able to do that from some of the sensor configuration, and we actually were able to double the recording time to bring it up to about 9 minutes, which allows us to evaluate the entire JBS with one single release rather than have to release a bunch of different sensor fish throughout the system. This really increases the options that we have moving forward for other evaluations of these longer structures that we might not have evaluated before. We also looked at the number of severe events by region within the JBS. Severe events are a really standardized metric that we use in sensor fish evaluations, and it's defined by an acceleration that's greater than or equal to 95 Gs. This is pretty common in a lot of the studies that we do, and usually we do it in a comparative fashion. So we're comparing two different operations or two different structures or pathways. In this case, we don't have the opportunity to compare to anything. We've never looked at a JBS before, and we don't have the information on the old JBS. So it's really hard to make any comparative, definitive statements about what this data mean. But we do know that there were severe events recorded throughout the JBS in all of the different regions. But again, the comparisons are pretty limited. And the relationship to the fish effects is a little bit questionable. We saw that the sensor fish traveled a lot faster than the live fish because they're neutrally buoyant and passively moving through the system. And from our fish condition data, we saw that there wasn't any evidence that the fish were really acquiring any injuries or experiencing any of these severe events. So this data we're still interpreting. So kind of moving forward, or to conclude on the results that we saw this year, we had a significantly lower descaling rate for fish that passed through the facility bypass route, and that was compared to previous evaluations. We did see that the fish moved slower, particularly the fish that we released into the gate wells, but the run-of-the-river fish that moved through the system this year, their travel rates were really comparable to what we've seen in the past. We also saw that the sensor fish travel rates varied quite a bit, but they were overall much faster than the live fish that were released into the system. And also the sensor configuration really allows us to expand our data collection period and really improve future evaluations. And finally, not to steal any thunder from Dr. Skalski, but when we looked at the acoustic telemetry data and looked at all the species and stocks that passed through the JBS at Lower Granite this year, we saw that survival was greater than 99.5% for all of them. And with that, a number of folks we need to thank: Derek and Dave and Eric from the district office, Elizabeth and Stephen and their team at Lower Granite that were phenomenal in helping us to execute this project, the smolt monitoring program that really helped a lot as we collected this data, Nicole from Batagas, and a number of my colleagues at PNNL. And with that, I can take any questions if there's time. Sweet.